This activity is a continuation of lesson 7.1 day 2, in that we are going to be looking at two special cases involving similar triangles. The first one involves rays from the sun, and those rays are creating shadows, and so in doing so, if these two objects are fairly close to each other, these two angles here would be the same angle measurement. We're going to assume that the clock and the stick, for example, are vertically to the ground. Therefore, that creates the second special angle. And then, based on our triangle congruency rule, the third and final angle of both triangles will be the same. So problem number 1 says which pattern, similar pattern is being illustrated here. So one thing we talked about for similar triangles, as well as similar shapes, is that the angle measurements need to be the same. And then in terms of the shapes themselves, they need to be the same shape, and we have to have some type of scale factor between the sides. And the truth is, sometimes we don't have all that information. But one thing that is always true is that the angle measurements of the three triangles are the same. The two triangles are going to be similar to each other. So which pattern is being illustrated? The pattern is angle, angle, angle. The three angles are the same. So since the angles are the same, in both triangles, the triangles are similar. So a lot of the problems we're going to be dealing with in this first section involves shadows. And so again, we're going to assume that the object, the people, the buildings, trees, whatever, are basically creating a right angle with the ground. The shadows themselves, assuming that they're fairly close to each other, the person or the objects, those two angles are going to be the same. And then the angle at the top of the object will make the third angle. One of the things I talked about in the previous activity is that circle one of the triangles that we're working with, and then use those numbers as the denominators. And then pair up the corresponding sides with those numbers. So for example, the 3 and the 75 would go together because they're both bases. The 6 and the x would go together because they're both heights. And then from here, we would cross multiply as we did in the previous activity to find out the height of the Statue of Liberty. So if I cross multiply, it's going to be 3 times x, 6 times 75. So 3x is going to equal 450. Divide by 3, and the approximate height would be 150 feet. So if you go ahead and take a look at problem B, and again, just circling one of the triangles, making those numbers the denominator. And when you're finished with problem B, turn the video back on. So again, we may select a different triangle for using the numbers on the bottom, and that should be okay as long as everything else is paired up correctly. So the 15 and the h are heights. The 25 and the 10 are bases. So these would be the pairing up the corresponding parts again. So the 25 gets multiplied to the h, the 15 gets multiplied to the 10. So we have 25h equals 150. And then if we divide by 25, h will be 6. So the height of the person is 6 feet. We have two more problems on page 2, C and D, and at the bottom I have E and F. So there's 4 problems total. So if you would go ahead and complete these 4 problems, turn the video on when you're ready to talk about them. All right, so problem C, again, I'm going to choose the triangle with both numbers. So 6.2 is the height and 10 is the base or the shadow. So the 10 goes with the 48 because they're both shadows. The 6.2 goes with the h because they're both heights. So we're going to cross multiply. So 10h is equal to 6.2 times 48. So 10h is going to equal 297.6, and then we divide both sides by 10, and we end up with 29.76 yards. Problem D, and I would probably use the person again, so I have both numbers. So the 2 gets matched up with the h because they're both heights. The 6 gets matched up with 72 because they're both shadows. So we're going to multiply 72 times 2, 6 times h. So it's 144 equals 6h. And then if I divide both sides by 6, I get 24. So the height of the building is 24 meters. So a meter is approximately 3 feet, so we're looking at about 72 feet tall. In problem E, compare 13 with the 39. And the 6 with the h being heights. And cross multiply, so 39 times 6 is equal to 13 times h. So 13h is going to be 234. And then if I divide that by 13, the height is 18 feet. And the last problem on this page, again, I would probably choose, again, the 3 and the 4. So the 4 goes with the 3, 36. 3 goes with the h. So if I cross multiply, it's 36 times 3 equals 4h. So 4h is going to equal 108. And if I divide that by 4, 27 would be the answer. So the tree's height is 27 meters, which is about 80 feet, actually 81. All right, problem G and H, they want you to actually draw the picture for what's happening here, and then try to set a proportion and solve for the missing piece of information. So if we go ahead and do G, turn the video back on to see if you did that completely. We'll go through that problem and then work on H. All right, so the building is the unknown piece to this. We know that the building casts a shadow of 420 meters. A person close by has a height of 2 meters and casts a shadow of 24. So again, I'm going to choose the person and have both numbers. So the 24 gets paired up with the 420, and the 2 gets paired up with the height. So I'm going to cross multiply, so 2 times 420 is equal to 24h. So 24h is equal to 840. And if I divide by 24, the height of the building will be 35 meters. So this is a very tall building because again, a meter is about 3 feet. So we're looking at buildings about 105 feet. So it's at least 10 stories. All right, to go ahead and work on problem H, and then turn the video back on when you're ready to look at the answer. So in this problem, the person's height is taller than the shadow, so that means that this sun definitely is very high into the sky. Not quite noon, but very definitely very high. So again, 6 and 2 would be my choices for the denominators. The 2 gets paired up with the 12, and the 6 gets paired up with the H. So I cross multiply 2 times H, 6 times 12. So 2H equals 72. So I divide by 2 and I get 36. So the tree's height is 36 feet. So as I mentioned, there are 2 types of problems that are being emphasized in this handout. So the first one is basically 2 objects that are very close to each other, and a sun is casting a shadow, and because they're so close to each other, the angle at which they are creating with the ground is the same, assuming the objects are, let's say, vertical to the ground. That means we can create that right angle, top angle will be the same. This one here, we're looking at a person looking into a mirror, something that you're going to be doing on Friday, looking into a mirror and trying to put him or herself in a position so they're able to see the top of the light pole. And they're trying to figure out, based on their position, how tall is that light pole. So the question here is the angle created by the mirror, by the person and the object are the same. So this angle here and here are the same. And we're going to assume that, again, the objects are perpendicular to the ground. So these 2 angles here and this pole here basically are creating that second angle that are the same. So both triangles are similar by this angle idea that we talked about earlier. All 3 angles are going to be the same, because if the 2 triangles already share 2 pairs of angles that are the same, then the third angle has to be the same. So again, we don't have numbers in terms of lengths, but we do have enough information to say these 2 triangles are going to have to be similar because the angle is the same. And this goes back to the work that we did day 1 last week. Is that when we have it's the only rule that from that first day handout that continued to work throughout is all the angles are the same. Sometimes you can look at rectangles and they may have different scale factors for sides, which made them not similar, but the angles were always the same. And so in these triangles here, we're looking at 2 right triangles, and we're going to, since all the angles are the same, these triangles are going to end up having that same shape. So here they're asking the question, if I separate proportion using A, B, Y, Z, what would be the best situation in terms of pairing things together? So why don't you go ahead and take a moment, turn the video off, complete this, turn it back on when you're ready. So one of the things I've tried to do is be consistent about the lengths. And so when I look at the Y and the A, these being my denominators, the A and the Z I pair together as being those heights, and the B and the Y I would pair together. Not as shadows this time, but basically the distance the object is from the center of the mirror. So these are again called the corresponding sides. Now, if you paired them up differently, for example, had a different reason, and if you cross multiply, for example, and you actually get B times A is equal to Y times Z, your proportion would also work. But again, I like to do corresponding pieces, and I always find that has always worked out well for me. So we're going to be looking at some problems in which you're looking at a mirror, or someone's looking into a mirror and trying to determine different heights of objects based on seeing the top of that object at the center of that mirror. And again, we have basically the distances that the center of the mirror is from the object, and then we have the heights of the object itself. So we're going to set proportions in a very similar way. And again, I'm going to continue to use that corresponding piece. So if you go ahead and complete the first problems here, and there will be a second video that will complete these problems as well as the rest of the handout.